Looking at our Multisim schematic, we have our 4 diodes that are connected in series parallel with each other. D1 and D3 would activate at the same time when there is a negative connotation, and the D4 and D2 would be activated during the positive connotation. Notice D1 and D4 have their cathodes facing each other, and D2 and D3 have their cathodes facing away from each other. R1, the 2.2K ohm resistor, is where we're measuring our pulsating DC voltage off of. When we go into run the schematic, our function generator is producing 100 hertz with a 5 volts peak. When we look at our oscilloscope, we can see that we're creating a pulsating DC voltage that is twice the frequency of the input voltage. Notice that it is off until it receives 0.7 volts for biasing positive or negative. We have these flat valleys, and then once it is on, it continually creates a positive output voltage that once again is slightly less than the volts peak put in due to the forward biasing voltage being used. And then moving on to our board setup. For our board setup, we have on this side our 2 diodes with the cathodes pointing at each other. On the other side, we have the cathodes away from each other. Bridging these 2 segments, we have our 2.2K ohm resistor. I'm currently on one channel reading the voltage of the 2.2K resistor. Bridging this portions, the diodes together so that the power would be applied to them across with this wire, and then our power being applied from the board with this wire over to here. Same over here, we have the green wire connecting the diodes on this portion, and then this black wire connecting over to our return, which is over here. Moving into our waveform, our created voltage in our wave gen is 100 hertz at 5 volts peak. When after it started, if we go into our scope, we're creating a similar voltage to the Multisim. We have our 0.7 volt valleys from the forward biasing cost of the diodes, and then a pulsating DC voltage that is a frequency twice that of the input frequency. Looking at our voltmeter, notice we have 2.021 volts DC, and our input voltage, this is in DC because if we were looking at AC waveform, if we look at our volts AC, this is our pulsating AC DC current of 2.39 voltage. This is the difference where our input RMS was 3.56. We go back and look at Multisim. And we look at our voltage meter over here, we're 2.084 with a difference of about 0.06 volts, which is well within the difference.